Alright, Unit 3.3, we're going to go look more in depth at quadratic equations before we take off and start focusing on just in general polynomials. So quadratics being a specific type of polynomial where your degree is 2. When we have a quadratic equation, or quadratic equation, excuse me, we have two formats it can come in. Kind of like with linear equations, you have a standard form and then you have a slope-intercept form. With quadratic equations, we have a standard form, which still has the a, the b, and the c. But then we also have our vertex form, which is very informative because with our vertex form, we have this a, h, and k that we can then identify things with, just like we saw with the transformations of the quadratics in the previous videos, or absolute value functions, or whatever it was. All right, so a couple things about these guys. Let's see. I don't know. I think the main thing to copy down here is just you need this table. You need this basic format of vertex form. You need its layout. You need to know that the a value out here in front, if the a value is less than 0, which means it's a negative, and we're going to look at some examples of this, but if your a value is negative, then you have a reflection over the x-axis. If your a value is a fraction, meaning it's like somewhere between 1 and 2, like 1/2, 1/4, 3/4, 7/8, a fraction, then you have what's called a vertical shrink, meaning that your graph, if your parent function was this, then a vertical shrink means that you basically take that graph and it shrinks out. It kind of is like being squished. If your a value is greater than 1, in that case there, you have what we call a vertical stretch, which basically means you take it and you stretch it out so it grows faster. So this would be if your a value was 3. Out here, the red would be like if your a value was 1/2, it's a fraction. And then obviously the blue one is your parent function. That's the original quadratic of just x squared. We look at the h value. With the h value, that's a horizontal shift, which we already saw with our previous transformations, whether it be with a quadratic or a cubic or a radical or absolute value, whatever it was. We saw that moved us side to side, and then we had our k value was our vertical shift up and down. Remember that the h value is always going to be negative. Alright, the cool thing about vertex form is that you can see those things. You can identify and tell those things quickly. In this case here with standard form, you can't. Alright, so keep that in mind. Alright, so let's talk about the parts of a parabola. Now that we've talked about how we're going to tell characteristics about, let's look at the pieces of it. So let's start off, and we'll start off right here. And these two guys right there, those two guys would be called our x-intercepts. Alright, so we got our x-intercepts right there. We got our x-intercepts right there. We keep cruising along. Let's go ahead and do our y-intercept. Y-intercept. So right there, and grab this, and so that means that this would be our y-intercept. Alright, we have this special spot down here at the very bottom, and that special spot down there is called our vertex. And there's even something more special about that, is that the special name for that vertex is also known as our minimum. So that vertex is a minimum because it's our absolute lowest point of the graph. So that right there is our vertex, which is known as our minimum. Alright, let's see what else we have up here. Axis of symmetry. Our axis of symmetry is the special line that passes through the vertex. So we have this special line that's vertical, straight up and down in the middle of our parabola, passes through our vertex, and that's called our axis of symmetry. So let's go ahead and move this over here. So that's our axis of symmetry. Our axis of symmetry is unique because it's identified based upon its location in the vertex. So our axis of symmetry will be an x equals. And since our vertex passes through x equals 1, our axis of symmetry will be x equals 1. Alright? The cool thing about the axis of symmetry is it splits your graph in half. It makes your graph symmetrical. So you can see that if I folded this right-hand side over on top, it would match up perfectly on the left-hand side. So it's like a line of symmetry, which is why it's called the axis of symmetry. Alright, so go ahead and take a minute here, hit pause, draw this guy up, and label its parts. Okay, so once you come back, you're back from drawing it out. Let's go ahead and label those pieces. So we start off right here. We have those two spots. Those two spots right there would be known as our X-intercepts. We have this spot right here, which would be known as our vertex, which in this case would be a maximum. We have this spot right here, which would be a y-intercept. And then we have our axis of symmetry, that special line that passes straight through, and that would be known as our axis of symmetry. In this particular case, our axis of symmetry would be x equals positive 2, because it passes through that 2 value as a vertical line. So those are our parts of our parabola and the lead up to it. I'm going to stop this video right here and we'll pick up. That'll be kind of our introduction to parabolas and quadratic equations.